May the something be with you. Okay, so you can assume mass is a constant and take it out of the differential. If you take the derivative of velocity with respect to time, you get acceleration, and you get the force. May the force be with you.
Hola amigos, welcome to Sanchineering. So I've gotten some requests on like tips and advice on how to study for physics. So in this video, I'm gonna just do a little vlog, a little talk about my experiences with physics and what I think you should do. So here's my TLDR in case you don't want to watch all that. Number one, you do you. Everyone has their own opinions on how to study for something. You could be a really math-oriented person, or you could be a really conceptual-oriented person. Everyone has their own ways of studying, so just because I or someone else tells you how to do something doesn't mean it works for you. Number two, more than likely if this is your first time taking physics, it may be challenging, so my best recommendation is to work hard and stay motivated. Number three, a lot of science and engineering is based on two things: learning a principle and applying it to solving an application. So you're gonna learn a concept, solve a practice problem. Derive an equation, use that equation to solve a problem. You're always learning something and then using that to solve something else. So those are my quick tips, and then we'll get on with the main vlog. Disclaimer, I'm an undergrad who's not studying physics. I study chemical engineering, which uses a lot of the principles of it. If you have any questions, feel free to ask me. I'm hoping that whatever I present is accurate, so be sure to check the description for any updates.
Friends, before we get started, I was editing and I realized I forgot the most important thing. If you don't listen to any of this, but you listen to just one thing, it has to be this: practice makes perfect. I hate to say cliches, but it's honestly true. I was editing and I realized I forgot to mention that, and that's like the most important thing. You have to practice. Don't memorize, just work your butt off to understand how to solve problems, and it will come to you. All right, so let's get on to the main part of the vlog.
Wait, any tips?
Don't do it.
Okay, so what the heck is physics? So physics is the study, the math, whatever you want to call it, of the way things move. And that's extremely vague because physics is extremely broad. We're going to cover this in three forms, starting with high school physics, college level physics with a little bit of calculus, and calculus-based college physics. So as I said, physics is the study of motion, but more so I think of physics as the study of dimensional analysis. What is dimensional analysis? Well, first of all, I have a playlist on each of the topics in dimensional analysis, so check that out somewhere. So dimensional analysis is the tool, the mathematical model that allows engineers and scientists to make equations about the world. And sometimes it can be really intuitive, such as length, the length dimension, how long is a rod in the length and width and height, as well as mass, how heavy is this rod? And by giving it motion, now we're developing more tools. Now this has a velocity, acceleration, I'm giving it a force, right? All of this is physics. So the dimensions we'll cover are mass, length, and time. And we'll do different combinations of those. And the reason I think dimensional analysis is so important is because if you understand how they work, then you know how to use the equations. On the exam, they're probably not going to ask you how to derive. Instead, they're going to ask you to use that equation that you've derived and apply it to either a practice problem or a system you might see in real life. Okay, so in high school physics, you're probably not going to do a lot of derivations. You're going to go straight into the equations as a given. Your job is to figure out how to manipulate them to solve a problem. And we'll probably do some more examples later on. In a non-calculus based college level physics, you're going to probably do some derivations in class, but not go too in detail. Your job is to try to correlate the concepts and use those concepts to help you understand how to use those equations. In a calculus-based physics class, you're definitely going to go hands-on into the derivations and learn how these equations are made, where they come from, and then use those principles to solve even more complex questions. Now here's the correlation between the three. For all three, you're going to have to understand the concept and you're going to have to learn how to apply it. Whether you do the mathematical derivation or not is based on your level. But even if you don't go through the rigor of the mathematical derivation, you can at least conceptualize where these things come from. It may not make sense now, but in going through your classes and doing a lot of practice problems, it will eventually come to you. Trust me, I'm the kind of person that really takes a lot of time to understand a concept. But by putting in the effort, I'm molding my brain to practice and work itself out. Because the brain is, you have to work it out like a muscle. There are two main things that you do have to focus regardless of what level. Understanding some concept and doing an application of that concept, whether it's solving a problem or thinking about a solution. In high school, you're probably going to see a lot of multiple choice based on concepts and maybe a few math problems that test your ability. In college, you're going to see a little bit less multiple choice and more applications. And if you're an engineer or a physicist, it's probably going to be mostly solving problems. I know physics and engineering and all these science classes can seem difficult, but just trust me, if you just try to go through the problems and understand the solution, eventually it'll make sense. And yes, it is difficult, but it's fun, you know? This is physics. Rockets are physics, cars are physics. You walking and breathing, all of that is physics all around you. It's science, man. Okay, let me give you a little scenario. I took like a physics type of class in high school. I failed it. Well, I didn't fail it. I got I think I got a C or a D. But anyway, I just felt like and now I've applied myself more in college and now I love it. I make videos about physics. You can use physics to calculate how powerful Blastoise is. You can use physics to derive other principles used in engineering. Just try to motivate yourself, okay? Watch physics videos. Watch Minute Physics. Watch Doc Physics. Watch Vsauce. Watch ASAP Science. You know, well they're mostly like biology based, but watch Sangineering. So this is just a general overview of how you should prepare yourself for a physics class. I won't go into too much detail yet, but if you like this, I may give some examples of how you can do some applications of what I'm talking about. I'm hoping this isn't too vague, and if you want me to go more in depth, maybe do some examples, definitely leave a comment. I'm thinking of doing some more videos on fluid mechanics because that's definitely my favorite class and it's based on physics. If you enjoyed this, then tell me what I should do, and I'm thinking of doing some more videos on dimensional analysis. I'm hoping that it will help people to understand where these principles come from. Be sure to check out my website. I definitely have more material on dimensional analysis. And if this improves, then I'll definitely add some more examples and some trick questions that have definitely stumped me over the years. So I hope you guys have enjoyed this. If I forget anything or mess anything up, I'll add it to the description. Feel free to ask any questions in the comments, maybe some kind of request for a video you want to see.